Good evening all, thank you for coming. Tonight I'm delighted to have Glenn Clowder join us, Eka, or also known as Astro Bloke on his YouTube channel. I'm sure you've all seen his channel. Glenn's driven 2 hours to come and see us tonight, so I think we should applaud him for that anyway. And Glenn's kindly brought down his Meade telescope, and he's going to tell us all about it, his project, restoring it and getting it in good running order, and tell us about his journey with it. So let's put our hands together again for Glenn. Thank you very much.
Well, thanks ever so much, everyone, and it's nice to be back. I know I've been to see you all before, and I sort of talked about my general journey in astro. So if you weren't there, you'll have to just catch up with something. As I say, I do a YouTube channel called Astro Bloke, and that's also all my social media, so you can catch up with me on there. I'm plastering rubbish all over the internet, winding people up, so it's good fun. So I've been doing astrophotography since 2019 properly. Always dabbled, star trails, you know, time lapses, things like that, but got into astro properly in about 2019, and I've been on a bit of a journey building an observatory. I've got lots of scopes. My favourite scopes are Newtonians, basically. I don't know, some people like them, some people hate them. Newtonians for me, bang for buck, can't beat them. I wanted to get something with a bit more focal length. I used to have a Ritchie Cretchin an RC8 by Altair, which is 1,640 millimeters focal length f8, and I did really well with that scope, and I actually got a NASA A-pod working with some other people in 2021, and then I sold it because when I bought my Orion Optics CT10, which is my carbon fibre Newtonian, it was the same focal length as the Ritchie Cretchin reduced, and I just thought, if I want more focal length, I'd rather go for an SCT. That was my thought. I sold the RC8 and didn't have it for a few years. A year ago, this came up for sale, and I was very lucky to see it. So I snapped it up because it was £400 for this Meade SCT, and that included the Moonlight focuser on the back. And I thought a Moonlight focuser's worth 400 quid, pretty much. So I snapped it up. I was jokingly saying earlier on, I actually bought it from the grumpiest person I've ever met in astronomy, but we'll go to that another day. He was really grumpy, but never mind. So anyway, I bought it and never had an SCT before, wasn't sure about everything with it. And because of the Moonlight focuser, I was like, at first I wasn't sure about how connecting everything. Got everything on, and it kept clashing with the coarse focuser knob. Now, do you all know about these scopes? Any of you got these scopes, or do you know about them? Yeah? So it kept clashing with this, so I thought, oh, this is not needed really. I'll take it off. Has anybody ever taken one of these off? Okay, so I unscrewed it, and it just kept unscrewing for quite some time, till the end it fell off with all of the mechanics behind it attached to the mirror, and it just all hung out the back, and I was like, don't think it's supposed to do that. So I kind of put it back together-ish, put it on the side, and it sat there for a year, and I never used it. Now, I've got quite a lot of scopes at home. I've got about 8 in total, so I've got plenty of other scopes, so I carried on with them. But this year I thought, I'm going to get this up and running. Okay, so first job was to put the focuser back together, which actually wasn't as bad as I thought. Got it back in, and then I started looking at collimating. So with my Newtonians, I've actually got a Harry Glatter and a tube plug for defocused collimation, and that works pretty well. But with the SCTs, what I've actually found the best, I tried the defocused donut method. I wasn't very good at that, to be honest. I ended up chasing the donut hole round and round and round. So what I ended up getting was one of these, which is a tri-Batanoff mask. Now, has any of you used these? Okay, recommend these highly. So when you put it on normally, you get 3 sets of diffraction spikes. You end up with diffraction spikes everywhere. It's quite confusing. But put a normal batten off mask on, get it in focus, and then with this, with the mask, what it does is you line it up with each of the screws on the front. So I'm going to take my rather nicely made, that comes off really easy because it doesn't go on very well. So at the front, these are your collimation screws, and you've got 3, and you have to operate each one at a time. So basically, when you put the mask on, you actually have the arrow pointing at the screw that you're going to be doing your adjustment on. I'll get that out of the way, and then you can all see what's going on. So basically, that arrow, that sort of V, points at this screw. When you put the mask on, you end up with 1 diffraction spike like you get from a normal batten off mask. And what you do, you get yourself in focus to start with, and then with this would be on this axis. So basically, you would either loosen or tighten that screw and do the opposite with the opposite 2 screws until your batten off is in focus, yeah? You've got no tilt showing whatsoever. Once you've done that, you then just rotate it to the next one. And you do the same again. Loosen or tighten this, and loosen or tighten the opposite 2, and get that to do it. And then you keep going around. And you might have to go around a couple of times before it all, because what it does is it sort of slowly brings it into collimation. But I found that this definitely, without doubt, gets the best collimation from the scope. I tried the donut method, and it didn't work for me. I got this from Thinkable Creations, they're in America. I got them off, it came through eBay and on Etsy. And the guy's called Nick who sells them, and he's really nice, really friendly. But I don't know if he does larger, because Kevin was asking, he needs a large collimation mask. So, but don't leave them out in the sun, they warp.
No.
All right. So focal length of the Meade is the same as the 8-inch Celestron. It's 2032 f10 native. I do have a reducer for it. It's a 0.63 reducer, but I've used it and it's fine, but I'm like, it's not what I bought it for. I bought it for the reach, so I don't want to start reducing. I know it speeds it up, but you know, but when you're getting on galaxies, I've found f10 is fine because they're quite bright anyway, you know, and I want to do some planetary. And that cheapskate company, SV Boney, sent me a planetary camera, but I haven't been able to use it. It says no planets. I don't know if you've noticed, they're all below the horizon until the early hours of the morning, and I'm asleep then.
Good on the moon then?
Huh?
Good on the moon then?
Yeah, it was cloudy when the moon was out for me. And I've become extremely lazy now. I've got an automated observatory and I've got a Lunatico cloud watcher running everything, because I can just basically go to bed and it does everything for me. So if it clouds over, the roof shuts. If it rains, the roof shuts. If it clears again, the roof reopens and everything carries on. So it's like having an assistant. It's brilliant. Best £300 odd I ever spent actually. So really good. This is not complete. I do normally have a guide scope on the top here. Now this is the area that I need to make my next changes. I've got a William Optics Zenith Star 61 on the top, 360mm. It's not really enough, to be honest. The only problem is the plate that it comes on is a William Optics 30cm plate, and it's gold in colour, and I'd say it weighs the same as gold. Honestly, the weight of it is ridiculous. And when I had this originally, oh, it's here, look, I've got a picture of it, there it is. And I had this originally on a cage. I don't know if any of you have done that with your Lost Mandy plates. You make a cage and it gives you great place for all your cables, your mini PC, your power box. It's really neat and tidy. However, it's heavy. So when I weighed this with the guide scope on the top, I was getting close to 14 kilograms. And on the Zenith, on the EQ6, that was kind of like, I had 4 counterweights on it. It wasn't very happy. It was working, but it wasn't really ideal. So you can see the counterweights there. So I started stripping it back a little bit. I took the cage off, and as you can see here, I've got my mini PC mounted there and the power box there. And that's improved things quite a bit. I actually took quite a lump of weight off. The problem is the the name of it's gone out my head. What's this called? Moonlight. The Moonlight focuser. Thank you, Moon. That's really heavy as well. It's a real chunk of metal. So what I'm actually going to do is I'm going to remove these brackets off the top, and I think I'm going to go with an off-axis guider at the back. Okay, I'm going to have to see how it goes, because the Moonlight focuser takes up most of the 109.5 millimeters backspacing, but I think if you go over, it just causes problems at the edges, and I think it actually increases the focal length if you're further away. So we'll have to see what happens. I'll have a play with it and I'll report back. You can all have a laugh at my expense. I'll be the guinea pig, if you like. But yeah, that's where I'm going to go next. At the moment I've been using the 533 one-shot colour, but I'm going to use the 294 mono with a filter wheel and off-axis guider. So it is going to add maybe about another 20 mil to the back there. I don't know how I'm going to get on with that. I think it's at about 111 at the moment, so it'll be 131. So I don't know. It might not work.
What's the backspace in the 533 camera? The sensor from the camera?
On the ZWO, they're 16. No, they're 17 and a half.
Good, because the 294 is 6.5.
Yeah.
And that's 17 and a half, is it?
Yeah. With the
It's usually got an adapter ring on.
Yeah, with the adapter ring on it is, yeah.
The 5, yeah.
But I can actually get my 294 screwed straight into my. I've got a. I bought it actually from TS Optics, funny enough, years ago, and you can't buy them anymore. They did this little skinny. It's literally 4mm thick rotator.
Yeah.
It's basic as you like, but it works. It's just got 2 little thumb screws on it, and you just manually, and that allows you to screw a camera into the filter wheel. So that'll help. I'll do that, and I'll see how it goes. But I've had a lot of fun with this, and what I wanted to do with it was galaxies. So that's what I bought it for, and I thought I would share with you some of the images that I've taken with it. But before I do that, have you got any questions? Anyone want to know anything? Or
Have you thought about the Duo camera, the one with the guide chip in it?
I haven't, but that's an idea actually, because that wouldn't need the backspacing then.
You wouldn't need a micro PC to run it either, because it's got half a terabyte of memory on board the camera.
Yeah.
And the new 585, which is coming out
Yeah.
soon, I think it's going to be.
That'd be good.
It's quite a small chip.
Yeah, it's quite small.
But
The only problems I have with that is I have to stick with a mini PC because I run instances of Nina, and I have to run instances of Nina on this as well as the main rig because it's in my observatory. So if my cloud watcher detects cloud or rain and it's going to shut the roof, this has to know that the roof's going to shut and park.
So you can't use an ASIE.
So you can't use an ASIE because an ASIE won't run my observatory.
Probably not.
Because I've got an automated roof. So basically what happens is Lunatico works on my main rig on that computer, and then through Alpaca, I don't know if you've used Alpaca Ascom, that then makes that driver an IP address. So this can then connect to that IP address, and it knows what the cloud watcher's doing. So if the cloud watcher says it's unsafe, both scopes park and the roof shuts. So if you didn't have that, because before I could have my scope up, but I was imaging the inside of my roof, which is pretty much a waste of energy, and you know, you're wearing your gear out, taking pictures of a roof, which really ain't worth having, you know, throw it all away. So yeah, that's how I've got it working at the moment. So and if you don't have that, the only other way would be to have a few Lunaticos, wouldn't you? That costs you a lot of money, wouldn't it? So
one thing, if with the inbuilt guider, the trouble is you're looking for the filter wheel, and an F10 through an HA You won't see any stars.
That's the
Well,
that is the issue.
I've never had I've had a slight problem.
You've got mono, though.
Yeah.
You've got colour, haven't you? One-shot colour.
Yeah.
Mm.
All my stars.
I'm not sure what mono would be like, but I suppose you'd have to not use 3 nanometer. You'd have to go higher, like 6.5 or something like that, nanometer filters. So.
Can you adjust the gain on each?
Yeah.
You can't, can you?
Well, in SIA,
Yeah.
I can adjust the speed of the guide.
In Nina, with the focusing, you can actually adjust
But
everything.
filter, that's the thing, you can't do it, can you? You can set it for the whole set.
Yeah.
So you could.
Don't forget with the Nina, you can set filter offsets, so you don't have to refocus because it automatically goes to the right
I was
focus
saying,
part.
if you was looking through HA,
Yeah.
if you could give it a higher gain on the camera, it'd work. But you can't just do it for one filter.
Yeah.
You've got to do it for the whole lot. So.
Not with if you're doing an autofocus routine with Nina, you can specify bin, gain, everything for each one.
Guide camera.
Yeah, the guide camera. I don't know how it'd work
No.
Yeah.
because that'd be through PhD anyway.
Yeah, but you can only do it for the whole camera and not for specific filters because it's not looking for. It doesn't know it's looking for a filter.
No, it doesn't. It would just be set. 'Cause it'd be set through PhD too anyway. So I don't know. I mean, it could work well. It's definitely a consideration. It's a good idea because it would save you that back focus.
One-shot colour. I mean, that's the
Colour camera, it's perfect.
Yeah, if you're using a colour
I
camera.
don't understand what you're saying.
Yeah, what's that then?
We have a minute.
Yeah, that's all right, that's okay.
One-shot colour versus.
That's okay. So anyway, that's how my scope was, and as you can see on the ground here, I've got all my nuts and bolts and screws and my Allen keys and everything because I've been taking it apart and tinkering. I love tinkering. I don't know about you, like I love tinkering, and I'm not there yet with this, but I will be. I'll get this as light as I can get it because I think that will help the EQ6. And yeah, I'm going to keep pushing with that. So
How much have you actually got to lose? About 15%, 10%
what's that?
off the weight.
I don't know. I mean, it's guiding now with the guide scope on the top. It's doing fine. I'm going to show you some images. You can see what it's done, but it's not ideal. I don't think. I think you know, the lighter I can get it, the better it will be, really. So, and also it just gives me something to keep me out of the house because if I'm in the house, I just get roped into other work. You know.
Like the
Popper jobs.
I get lots and lots of projects, I'm telling you. So, let me just show you what I've done. So, galaxies. So, has anybody heard of a Seyfert 1 galaxy?
I've heard of it.
And a Seyfert 2 galaxy? So,
I'd heard of it.
yeah, I'd heard of it, but I didn't know what it meant. Did you? No. So, I thought I'd share with you what it means. Okay, so a Seyfert 1 galaxy is a galaxy characterised by a bright, compact core and shows a very strong infrared emission. Okay? It's interesting, isn't it? And a Seyfert 2 galaxy it's got an active galactic nucleus characterised by narrow emission lines in its spectrum. So unlike Type 1, which displays both broad and narrow emission lines, the Seyfert 2 only shows narrow lines. And that indicates it's got lower velocities of gas in the central region. And these galaxies are thought to be powered by supermassive black holes at their centre, and the presence of the narrow emission lines suggests that the central region is obscured by dust and gas, preventing us from actually seeing the broad lines. Okay? There you go. Don't say you didn't learn something. Okay, I'll be asking you to repeat that at the end. So anyway, I've imaged the Leo triplet many times in the past and never been happy with the results personally, and I don't know how you've all got on with it, but this was the first time I've imaged the Leo triplet and thought, oh, I quite like that, it looks nice. So this was one I took, and this was taken with my Newtonian while I was still trying to sort out the SCT, and give you a little bit of details about them. This was taken with my CT10 with the 2600 Pro, and I took L, luminance, HA, RGB, and there's 12 hours of data here. Okay. As I say, very famous triplet. Most people know it, and it's made up of Messier 65, Messier 66, and NGC 3628. Okay, so Messier 66 is a spiral galaxy, 95,000 light years away. It's got asymmetric spiral arms. Okay, and was lightly distorted by gravitational interactions with the other two. So there's triplets in space that are just together because of line of sight, and then you've got triplets that are in space that are actually together and they actually interact with each other, and this is one of the ones that actually interact with each other.
95 million light years, I think.
95,000 light years across, not away. Sorry,
across.
Did I say from?
You said away.
Oh, 35 million light years away.
Yeah.
You know, it's just down the road. Not far, is it? So, yeah, 95,000 million. How does it look up there? Right. Does it look any good?
Yeah, it does, yeah.
Does it? Oh, good.
Question, so what was the ratio of luminance and HA?
So I tend to, well, what I'll do is I'll do LRGB are normally about 3 minutes subs. Unless I'm getting problems with it blowing out anywhere, then I might drop the luminance, and the HA 5 minutes. But it depends on the target. A lot of targets I'll do 10 minutes with HA because it's 3 nanometers.
So but the ratio of RGB versus luminance and HA. So
I would say I do
not this individual
a
stuff.
good 3 to 1 luminance to RGB.
Yeah.
And then HA,
As much as you can.
it just depends on how much is coming out. I mean, you know, if you get to something like M106, it's got a lot of HA in it, or Andromeda even, then it's worth pushing. But some galaxies I found, you push the HA and you just literally, you know, you're not getting anywhere. You're not getting much. Yeah, you're not getting much. So it just depends on the actual galaxy itself. Let's have a look at another one. Oh look, that one. I like this. It's a pretty one, this one, isn't it? This is Messier 66, another intermediate spiral galaxy, same size as the other one, about 95,000 light years across. Galaxy displays unusual spiral arms, again likely distorted by the other two, 65 and 3628. M66 has hosted 3 supernovas since 1989, which you might not know, which highlights its extremely dynamic nature. Past encounters with 3628 have led to high central mass concentration and a disrupted gas structure. Ooh. Right, and then finally, known as, what is it, Hamburger Galaxy?
Yeah.
I quite like this one actually. NGC 3628 Hamburger Galaxy, Edge-on Spiral Galaxy, 150,000 light years across approximately, so a lot larger than the other two. And it's got some unique features. It's edge-on, reveals prominent dark dust lanes, which I think you can see, and it's got a tidal tail, a long tidal tail, which they say is a result of a gravitational interaction with the other two. So they're all affecting each other basically. The galaxy also exhibits an X-shaped bulge, possibly indicative of a barred spiral galaxy viewed edge-on. See, that was a supernova. There was another one just happened there, live on the chat. Okay. Right. So I'm going to jump on to an image taken with the SCT. Okay. Now, when I first got the SCT up and running, I had no guiding. So I didn't have these 2 plates here. There was nothing on the top. And then I got these 2, and I didn't have a plate that fitted it. So I was like, oh, I've got no. And I wanted to try it out. So I went on M51, the Whirlpool Galaxy, and this is 2.5 hours with the 533MC, 30-second subs. So quite a few subs. But if I pushed it over 30 seconds, I'd get streaky stars. But I actually think for 30-second subs at f10, that's not bad. You know, come out quite well, really, isn't it? You know, so not a bad one. It's Whirlpool Galaxy. We must be all. Have we all photographed this one? We should have done, shouldn't we? Really. M51 is 31 million light years away. It's in the constellation of Canis Venatici. I like that name. It's nice. Very iconic, as I say. Most people, if not everyone's, imaged it. It's a grand design galaxy, and it's about 60,000 light years across. I reckon it contains over 100 billion stars, which is quite a crazy number, really, when you think about it. And they think it's about 400 million years old. It's got very strong star forming regions within it. So in the bright blue and pink areas, that is where the active star formations are actually occurring. And it's got a central black hole, supermassive black hole at the centre. Current rate of star formation is about 1% efficient, which is comparable to our Milky Way. Okay. It interacts with its little neighbour, NGC 5195, smaller galaxy, gravitationally within M51, and the interaction has obviously triggered the formation of M51's prominent spiral arms. Now, that's through the SCT, and then I thought, oh, I'll have a look at it through my Newtonian, because obviously I'm a Newtonian geek, as we all know, and this is through my SCT Newtonian. We've got another little galaxy up there as well. And I pushed a bit more on this one. I'm trying to think how long I took this picture for. Oh, 33 hours of luminance, HA, RGB. Again, same sort of thing with the 2600mm. And yeah, you know, the SCT does a great job on galaxies of a decent size, without a doubt. You know, you get really good detail. And yeah, I'm really pleased with that. It's come out really nice, actually. I was actually weird when I started Astro. Everyone was taking pictures of M51 and I refused to do it because I didn't want to be like everyone else. I don't know if that sounds... Does that sound strange? I just literally wouldn't do it. And I was like... And then when I did do it, I was like, oh my God, I should have done this before. I love it. But it's a nice galaxy, isn't it? So it's interesting.
Did you get the supernova that year?
No, I did on M101.
Right.
I got that supernova, but I didn't get the one on Whirlpool.
Was it
M101. I might have been at my fussy stage there where I refused to image it. But I like this one. I managed to get quite a lot of the filaments in the top end here, which I don't think I've caught them before. I've always got them at the bottom, but not at the top. So, is it coming out all right on there? I can't really see it.
Oh, the filaments are brilliant.
Yeah, they did come out nice on that one. Okay, so where are we going next? Let's have a look. Okay, so this is the Heron Galaxy. You know this one? Looks like a heron, apparently. So this would be the body, and this is the head. Okay, it's really small, and I tried to get my CT10 on this, and it was just too small, basically. So this is what this is for: really small galaxies in a, you know. But for me, I've seen some images of this. Obviously, we're talking top end stuff, which I want to try and improve on. So it's going to be I think with the 294, I might be able to get better resolution on it. But this is, let me just get my notes up here. Excuse me a second. Yeah, the Heron Galaxy. NGC 5394 and 5395. Okay. So they're approximately 176 million light years away, so it's a long way away, and it's small. It's in Canis Venatici again, and I quite like it because it's quite an unusual looking galaxy, and it wasn't one I'd seen before. So it was, you know, always like to go for something I've not imaged before. I took This is 25 hours of one-shot colour. That's for you, Stephen. With a 533 MC. So again, even the small sensor. The two galaxies are engaged in a gravitational dance. They reckon that they've collided at least once, if not more. And the interaction has led to the formation of tidal tails, elongated streams of stars, and gas particularly extending from 5394, the smaller one. I don't know how to get this, but they reckon over the next several 100 million years, these galaxies are expected to merge into single elliptical or lenticular galaxy. Does anybody know what a lenticular galaxy is? No. Okay, well, I'll tell you about that later. Both galaxies have had supernovas in recent years, so there's obviously a lot of activity going on in there. And the gravitational interactions between the galaxies have triggered bursts of star formation, particularly in regions of rich ionised hydrogen. And the larger one, 5395, hosts an active galactic nucleus classified as a Seyfert Type 2 galaxy, indicating the presence of a supermassive hole at its centre. Any questions?
Yeah, what's lenticular?
It's somewhere in between a spiral and an elliptical.
Yep.
Okay, so this was taken with the SCT as well, and this is known as the Waterbug Galaxy. And this came out of one of my live streams. So I was on a live stream, and we were literally, I was just doing this, saying what we could get on, and someone went 5033, well, they didn't say the Waterbug, they just said NGC 5033. So we said, okay, let's have a look, went on it, and I thought, wow, I like that. And we started imaging it, and this is what got back. So this was, again, bear with me 2 seconds, 29 hours. I do like to put a bit of time into my images, by the way, if you haven't realised. Again, it's the one-shot colour, the 533 MC. When I use the 533 MC, I pretty much, well, because it's the ZWO, it hasn't got a built-in UV-IR cut, so I'll usually use a UV-IR cut filter with that. And I've also got a tri-RGB filter, and I've got a dual narrowband filter, but I've not used them yet on the Galaxies. I've just stuck with the UV-IR cut, so that's what I've done with this. So this Waterbug Galaxy is, yeah, it's really interesting. It's an unbarred spiral with loosely wound arms. Again, it's in Canis Venatici. Everyone loves it up there.
Yeah, it's really nice.
It's nice up there.
Yeah.
It's 40 million light years away, and its diameter is about 100,000 light years. So similar to the Milky Way. It's a Seyfert 1 galaxy. Yeah, it's an active nucleus, making it a Seyfert Galaxy 1 and one of the brightest classes of active galaxy nuclei. So, yeah, it did have a really bright centre actually. So I had to be careful with the sub-length because I did try and push it and it blew out completely. So yeah, it's got a very bright centre. It hosts a supermassive black hole at its core, which actually powers the nuclei, and the emissions from it show very strong X-ray and optical activity. It's got quite an unusual core motion. The nucleus is offset from the galaxy centre, and that's possibly due to past mergers or interactions with other galaxies. There is another galaxy nearby called 5005, but it's a non-interacting galaxy pair, although they are close together in the sky and could influence each other gravitationally, but they're not visibly merging. So there might be some interaction there, but they're not actually merging together. I like this one. What do you think?
Yeah,
Right?
brilliant.
Yeah?
I really like it. I think it was about probably a month ago, and I was looking for new targets to shoot. So I got on Stellarium, looking at them, and I see that, and I thought I'd try it, and I did frame it, but I just thought it was a little bit too small. I thought about 1400.
Yeah.
A little bit too small, a bit.
That is actually cropped in.
Yeah, well, you can
And that is also with the 533 little 1 inch. I mean, yeah, with a APS-C.
Well, it, no, it's a 294, so that's what's that, 3/4?
Four thirds, isn't it?
4/3.
Yeah, 4/3.
So, yeah, it was a little bit underwhelming for me.
Yeah.
So I didn't shoot that one, but I did like it. The look of it, it's nice.
I mean, the 533, for this kind of photography, I think it's brilliant. I mean, you don't need that. I know people get a bit skewy about the fact it's a square sensor, but with a Galaxy, it's fine. And also, you don't even have to think about rotation. You just got to get it in the middle, basically, and it's there, and it works pretty well.
Anyway,
Yeah, you could crop it to that if you want to. Yeah, if that's the look you're going for. But no, the same as the 2600 and the 6200. It's 3.76. Yeah, it's the same. It's the same backlit sensor, just cut down. It's just cut down. Yeah, I bet that's good.
It's excellent.
Yeah, I bet that's really good. Yeah, I've tried the mono. Was it the mono or the colour? I've tried Altair's one. The only difference between Altair's one and the ZWO is Altair's has got a heated front screen, which ZWO don't, and Altair also have a built-in UV-IR cut on their sensor window, which the ZWO doesn't. I don't know whether later versions of that have been changed or whether they're going to change it, but it's a great little camera. I mean, I picked that up for £600 second hand, so I was really pleased with that. This, who knows what this is? Well done, M1 Messier. Guess what constellation it's in? Canis Venatici. Yeah, it's my favourite area. It's a brilliant area for galaxies. This was taken with my 6-inch Newtonian. Again, it's an Orion Optics. It's the VX6, the cheaper one. And you know, it's good because it captures all the other galaxies in the area. But then, of course, I use my favourite scope, my CT10, and you'll see why it's my favourite scope, because it takes a much better image of most things. You know, you're getting some really good detail on the dust lanes and everything. I need to push this a bit more to get the hydrogen spike coming out the centre. It's there, but you've got to stare at it. All right, so keep staring and let me know if you see it. So I took, what did I take with this? 12 hours of, again, luminance, HA and RGB. It's about 23 million light years away in Canis Venatici, as I said, and it's an intermittent spiral galaxy. Spans 135,000 light years in diameter, so it's slightly larger than our Milky Way. It's got anomalous arms. What a lovely word. Anyone want to try and spell that? No? No, you're not getting much in there. Come on, you can join in. Unlike typical spiral galaxies, it exhibits 2 additional anomalous arms composed of hot gas, and I think these are the ones that they talk about that come out of the centre. I think this is the start of one here, and I think you get another little one here, and they're mainly in HA, and if you really get a lot of HA on this, I don't know if any of you have done it. Yeah, you've done it. You get a real good prominent spike coming out the centre, which makes it look quite different to other galaxies. They believe that these arms are a result of energetic outflow driven by the supermassive black hole at its centre, rather than from star formation. So it seems like galaxies are mainly powered by either by star formation or their supermassive black hole in the centre. M106 is classified as a Seyfert 2. God, the knowledge level, it's come on. It's a Seyfert 2 galaxy. Indicates that it's got an active nucleus powered by a supermassive black hole. The black hole is approximately 40 million times the mass of our sun. That is just crazy, isn't it? Small?
Speck of dust.
Speck of dust. And consuming material at a rapid rate, influencing the galaxy's evolution. The galaxy hosts a powerful water vapour megamesa. emitting intense microwave radiation, and the phenomenon has allowed astronomers to measure M106's distance with remarkable precision, providing a critical anchor point for calibrating the cosmic distance ladder. So they obviously use this for all of that kind of thing. So they think it's got bipolar outflows. Okay, so observations have revealed large-scale bipolar structures emitting in radio and X-ray wavelengths, and I think things like JWST and things like that are now starting to see a lot of difference, because they kind of debunked a lot of their theories about galaxies, didn't they, with James Webb Space Telescope? Things that they thought they knew, this thing's gone, no, it's not that, and they've had to rethink, haven't they? And they reckon that's extending from the nucleus, and these bubble-like formations are thought to be the result of past energetic events linked to central black hole activity. There we go. That is an illustration of a bipolar black hole. It's the closest you're going to get without dying. So 2 supernovas have been recorded in M106. One occurred in 1981 and one in 2014. They've offered valuable data on stellar evolution and the death within galaxies. So there you go. Right. Next target. Anybody got any ideas what this is? Nobody knows it. So what I started to do was, with my Newtonian, I started picking on really small galaxies and sort of doing wide field images, because it was just something different, and I found it really quite fascinating. And when you look at these, especially on a computer, and you start zooming in, the number of galaxies you see is absolutely mental. It really is. But this is NGC 4151. I've taken it with LHA RGB. There's 15 hours here, and it's dubbed the Eye of Sauron. This one here. Okay, obviously because it resembles the Eye of Sauron from Lord of the Rings. It's possibly, now this makes me laugh, that M106 gives astronomers an accurate reading of how far things are away. So this is between 43 and 62 million light years away. So they give it like 1 minute they know exactly where something is, and the next minute they're like, well, it's with all, you know, give or take 20 million light years, which is like it's nothing, you know. Guess where it is? Canis Venatici, well done. It's got unique characteristics, and it's made its focal point in the study of active galactic nuclei and supermassive black holes. So they've done a lot of studying with this galaxy. It's an intermediate spiral Seyfert galaxy, indicating structure between barred and unbarred spirals with a weak inner ring. It's one of the brightest AGNs again known, but in the X-ray wavelengths, and it's powered again by a supermassive black hole. Some studies have suggested again that it's a binary black hole, so you've got the two going on in there, although they're still investigating this and they're not 100% sure. I think it might be from where, because it's too far away, maybe they can't see. It's one of the nearest galaxies with an actively accreting supermassive black hole. I didn't know what the word accreting meant, so I had to look it up, and it just means it's growing. So it's accumulating matter and growing in size. Okay, that's what that means. NGC 4151 serves as a valuable laboratory for studying the active galactic nuclei phenomenon and black hole growth. Okay. NGC 4145, which we can see over here. I'll just zoom that out a little bit so you can have a little look at everything. Is a barred spiral galaxy in the same constellation, Canis Venatici, and this one's got a central bar structure with loosely wound spiral arms. They estimate this again to be 44 to 68 million light years away, and it's got a unique feature of what they call flocculent structure. So unlike grand design spirals with well-defined arms, this has got flocculent appearance, which makes it look patchy and fragmented arms and gives it a kind of woolly, delicate look. It's a lovely description for a galaxy, I think. It's got very low star formation, so it primarily occurs in the outer regions, and it suggests that it's already formed the majority of its stars, and is currently in its quieter evolutionary phase. Potential evolution is due to its low star formation. Some astronomers predict that NGC 4151 may evolve into a lenticular galaxy in the future. So that means it's going to go from spiral to a lenticular, which then will become an elliptical, which is where you just get the ball of light, basically a rounded sort of galaxy with no detail really, just a ball of light. But again, I mean, I find these images quite interesting because of all these other, just whenever you look, like the extra little fuzzies and that, you know, and when you look really close on your computer screen where you've got your resolution, it's really quite fascinating. And I mean, I don't know about you guys, but I can sit and look at an image like this for quite some time, just going, no, look at that one and look at that one. And I'm yet to put this on Astrobin to get it to annotate it properly, but I will. And then maybe I'll find out what they're all called. But yeah, there's some great galaxies. That one over there looks really cool as well. I like that one there. So yeah. Right. So triplets. We've already looked at the Leo triplet. Do we know the Draco triplet? Oh, we do. This isn't in Canis Venatici. You'll be pleased to know it's in Draco. So there you go. So this is the Draco triplet. Have any of you imaged this one?
Yeah.
Because I hadn't before. This is the first time I've imaged this one. Okay. So this was 3.5 hours of just LRGB. I didn't find any HA in this, but this was small. So as you can see, this is at 900 millimeters, but f3.6. So my CT10 is quite fast because it's got the Star Arizona reducer. But you've got the 3 galaxies here, and it's quite good because it's got an elliptical galaxy. See, so we can all see what it's like. I haven't got any pictures of lenticular yet. I'll let you know if I get one. Right, so let's tell you about these. So first one, top one, is NGC 5985. And I think I've actually got, oh yeah, look, I've got this one done. So you can see the numbers. You can tell I'm not lying now. I'm not making it up. It's a barred spiral galaxy. It's in the northern constellation of Draco. 5985, which is below it, is actually a barred spiral structure with prominent central bar and well-defined spiral arms, but you can't really see them. It's recognised as a Seyfert 1 galaxy, indicating the presence of a... Sorry, I'm talking about the wrong one there. I'm talking about the top one still. Presence of an active galactic nuclei powered by a supermassive black hole, and is categorised as a liner, which is a low ionisation nuclear emission line region. I've learned so much. It's unreal. So that basically means it's got low level ionisation in its core. What that means, I don't know. Do you know? No, nor do I. Distance from Earth. So again, sources vary. They reckon it could be 120 million light years away. It's quite a distance. While others think it could be 140 million light years away. So again, we've got that little 20 million light year difference. Its diameter is estimated to be between 190,000 and 246,000 light years across. So it's larger than our Milky Way. The Draco trio, you've got 5985, obviously the main part of the visually striking trio. You've got 5982, which is an elliptical galaxy with a shell structure, and it's indicative of a past merger, and that's what's caused that to happen. And then lastly, you've got 5981, which is the edge-on galaxy, a spiral galaxy. And it says that while these all appear very close together in the sky, their actual varying distances suggest that the grouping is actually more line of sight coincidence. They're not actually together. They're just, you just see them together. 5985 has been the subject of various studies, particularly concerning its dark matter halo. So analysis of its rotation curves compared with luminous mass have provided insights into the distribution of dark matter within the galaxy. Any questions? We're all learning loads, aren't we? Silence.
I think you've got a new Glenn Sagan.
Safer.
Yeah.
So this one, again, this is the Splinter Galaxy, which I'm sure a lot of you know.
Yeah.
On the left. What actually drew me to this was I took a picture of the Splinter, and I knew it was a long way away, and it was the one to the right of it that grabbed my attention. So basically this is NGC's 5907, 5905 and 5908. There's 9 hours here with the CT10. Again, luminance HA RGB with the 2600. So the 5907, also known as a knife edge galaxy. It's quite a fascinating galaxy, located in what constellation? Distance from Earth is 50 million light years, and they reckon it's about 150,000 light years in diameter. Perfectly edge on from Earth, so hence why it's named the way it is. It's got a bulge in the centre, which is actually quite unusual for spirals, and has a faint extended stellar halo and low surface brightness. It features spectacular tidal streams along the arcs of its stars surrounding it, and which suggests again this has merged with other satellite galaxies. And it's located in the constellation of, you didn't answer, Draco, and it's particularly notable because of the unusual X-ray flare that's detected from its core in the 1990s, believed to be evidence of a tidal disruption event, a TDE. This was another term I hadn't heard of before, where a star is actually torn apart by the black hole in the centre. And here's some other facts. We're going to look at the other one, which is NGC 5905, which is this one here. 5905. Again, is a barred spiral galaxy. So I can get it up a little bit for you there. 150 million light years away from Earth, and again this had a massive tidal disruption event. In the 1990s, the Rossat X-ray satellite detected a dramatic X-ray flare from 5905. The flare was several times brighter than the galaxy's actual usual output, so they said it was due to a star being shredded by the galaxy's supermassive black hole, a classic TDE. The event provided one of the earliest strong places of evidence for dormant black holes in non-active galaxies. 5908 is an unbarred with moderately tight arms, 150 million light years, estimated to be 90,000 light years across. And 5908 is part of a pair with 5905, the other barred spiral, and they are sometimes referred to collectively as ARC 273. There's been a lot of studies with these. They look at them for galaxy evolution and morphology, star formation activity with edge-on galaxies, and X-ray observations looking at halos and hot gases. So it's interesting. They used to do a lot of studies with galaxies, don't they?
That looks like the classic flying saucer sweets.
Didn't it? It does. I want to. The one I've never taken is a sombrero. That's one I want to get on.
I'd love to do that.
Yeah, I want to get on that one. Yeah, it's low, isn't it? This is a well-known one, M100. Okay. This was a grand spiral design galaxy, and there is 12 hours of LRGB with the 2600 on the CT10. It's in Coma Berenices, approximately 55 million light years away and about 160,000 light years across. It was obviously observed by Charles Messier and it became his 100th object in his catalogue, hence the name M100. Again, it's one of the brightest and largest spiral galaxies in the Virgo cluster, which is a very large collection of galaxies, home to a very intense star-forming region. It's got a central bar, which is a common feature of many spiral galaxies, and that influences the star formation. M100 played a key role in measuring the Hubble constant, helping determine the rate at which the universe is expanding. It's had at least 5 supernovas have been observed in M100, and particularly important as it's well observed and helps understand the life cycle of massive stars. And again, with this image, there's just countless galaxies in here, little fuzzies. I'd love to look at this with a longer reach, you know, like those smaller ones and that, you know. It makes me just want to get a bigger scope all the time, which is dangerous, really, isn't it? You know, how big can you go, you know? It's like, it's a bit of a worry. Okay, this is my last image. So those of you that are struggling to stay awake can feel relaxed that this is not going on for much longer. So this is 3718, and lots of people have imaged this. It's a great galaxy. It's really interesting to look at. I like it. I remember when I first saw it, I thought, oh, I love that. It's really nice. So it's got intriguing features, which obviously captures the attention of a lot of astronomers. And you'll never guess what this type of galaxy is. Lenticular. It is a lenticular galaxy, yes. I thought I'd end with the star of the show. It's actually a lenticular, or also known as a peculiar spiral galaxy. It's in, anybody know what constellation this is in? Ursa Major, correct. Gold star. Ursa Major. It's about 52 million light years away. It's got warp dust lanes. It's especially known for its dramatic twisted dust lane that curves around the core, giving it its very disturbed appearance. The warping is thought to be a result of gravitational interaction or even a merger with a nearby galaxy, likely NGC 3729, which is located just 150,000 light years away. It likely hosts an active supermassive black hole in its centre, making it again one that's called a LINER, the low ionisation nuclear emission line region galaxy. So that means its core is letting off emits irradiation from ionised gas, possibly due to accretion activity around the central black hole. Studies suggest that 3718 may be merging system, and it could be consuming a smaller galaxy, which explains its distorted structure and dynamic features. It's often studied as along to Centaurus A, so that's the one they get in the southern region, isn't it? Another warped dust lane galaxy, helping astronomers understand galactic evolution and black hole feeding mechanisms. When I took this, I was obviously fascinated by the galaxy. I think it's great. I think it's a really interesting galaxy to take an image of. But what I found out, which was really interesting, was about this group of galaxies here. Okay, this is a group of 5 galaxies, and it's known as the Hickson 56, if none of you know that. And what's so fascinating about the Hickson 56 group is they reckon that it's about 425 million light years away. So I can pretty much think that's the furthest known object that I've got an image of, that I know what it is, you know. I mean, obviously we get lots of little fuzzies, but we don't know what they are. But this is quite, you know, and when you think you're taking an image of something that we're looking at the light that left that before the dinosaurs were walking around.
Twice.
It's just crazy. You know, when you start thinking about those numbers, and, you know, I mean, I tell my wife and she just glazes over. So she just goes, really?
Have you done Stefan's quintet?
I have,
Yeah.
but not successfully. Again, that's another one I've played with.
Hickson group, I think.
Yeah, I've played with, and then not actually ever. And then
It's tiny.
now I've done a really nice image of Leo's triplet. that's one I want to go to. And the other one I always see that I love the look of. What's that one that like a rose in a glass? Have you seen? What's that one? Have you seen that one?
I know the one you mean, but I can't think of it.
You can't. I could never find it.
Is that Luxembourg?
No, no, it's not that small. But I mean, there's loads out there, isn't there? I mean,
The trouble is, you can spend ages yesterday and Hubble's old pack now.
so I hope that wasn't too long with the galaxies. I know it was a lot of information and a lot of images there, but that's the thing I've been up to recently. So that's been like quite a new direction for me, and I think that's what's good about this hobby. In that, you know, for a long time I was on narrowband targets, you know, getting many hours, look at all those rich colours, getting all that sort of thing. But now I've like found this new sort of passion. I like going for galaxies, which I've really enjoyed. Planetary is also on the cards with this. God knows how I'll get on with that. I got on Mars and it looked like a fly had hit the front of the screen. I don't know what was going on with that. I couldn't get it to resolve or anything. It was just a blob that was just wobbling around, and I was like, I'm not blown away with this. So I'll have to see what happens. But Saturn and Jupiter are due back soon, when I'm actually going to be awake, which will be handy. So
Are they getting smaller?
they are, yeah.
And Saturn's rings are edge on now.
I'm also wondering with one of these what it's like with a Barlow. Yeah. Get a two or three Barlow. Get a Teleview. Yeah. Are they like the one to get?
Yeah, a lot more expensive than a Barlow. But,
Does S3 Boney do one? He's nodding. What's their one like? Any good? Yeah, I thought it would be. You can speak to my one of my YouTube supporters. He doesn't think S3 Boney's any good, does he? But anyway, no, I will finish then. So anyway, thank you ever so much. I hope it was of interest. That's what I've been doing recently, and I've really enjoyed meeting you all again. It's been really nice, and thanks ever so much for your hospitality.
Simon present to us. It was really interesting. I think we was all enthralled. We learned lots of new things, and we'll go away and research more of it. And it's really interesting what you're doing, looking at galaxies and focusing. I think it's something I'm going to do now. I think most of us will. But thank you very much for coming all the way down to see us, and we'd like to see you again one day.
Okay.
And thank you very much.
No, you're welcome.